binomial expansion thing was this Pascal's triangle. I think I started showing you guys.
My paper's better.
What happens is that if you take numbers and you just line a triangle, the outer edges of a triangle with ones, you can create a list that the numbers below are generated by the number directly above it. So here you start with one row. So we have one number, two numbers. This would be three numbers, four numbers, 5, 6, and 7. So this is how that works itself through. What happens is you start. What's that? These are just ones. This is like your 1, 2, 3 numbers. There'll be 4 numbers here, 5 numbers here. So this, I need another number here. I need 2 more here. I need 3 numbers here, and so on. What I want you to do is think of this in terms of as you start squaring things out. If you had binomials and stuff like that, whenever you had an x squared, how many terms would you could have? You could have 3. There was always n plus 1 terms within any polynomial. You'd have n possible zeros and going through all that. That's how we get number of terms. What's happening here is that you can get each of these specific values here. Oops, I gotta change that color. What's that? So each one of these numbers.
Why yellow?
I don't know. I just picked yellow. Oh, you can't see it very well though. Is generated from the 2 numbers that are directly above it. So what's 1 plus 1?
2.
What's 1 plus 2? 2 plus 1. 1 plus 3.
Is it just going to be the x?
Plus 3. I'm sorry, what was that? Lisa?
Never mind. Good.
And so on and so forth. What this is helping to show is that as you are taking polynomials, it gives you the coefficients of binomials squared, cubed, fourth, fifth, and so on. Whenever you take a binomial and it's junk squared, it was junk times junk. Junk cubed would be junk, junk, and junk. Junk to the 6 would be junk, 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 junk times junk.
That's a lot of junk.
It's a lot of junk. 6th degree junked binomial would have how many terms? 7 terms. Okay. So what's happening here is that if I FOILed this out, we get x squared plus 2xy plus y squared. Be right back. Notice 1, 2, 1. 1, 2, oops, and a 1. If I multiply that again by another x plus y, isn't that the same thing as saying x plus y to the 3rd?
Yeah.
So FOIL that out or distribute that out. I'm going to get an x cubed plus 2x squared y plus xy squared plus x squared y plus 2xy squared plus y cubed. Just distributing through, and then I combine my terms again. Now, when you combine your terms, you'll notice you get x cubed, 3x squared y, 3xy squared, and a y cubed. What's that? And that's the coefficients of 1, 3, 3, 1. What happens here then is we're actually using what's called Pascal's triangle to use binomial expansion. I also want you to take a look at the exponents. Notice what starts with your exponents, the degrees, the nth term. The next one has that degree does what? It goes down 1, then it does what again? It goes down again, and then it goes to 0. What is anything to the 0 power? 1. Now notice, the other one is ascending. the first term is descending. The first one, or the second one, is ascending. Y to the 0, y to the first, y squared, y cubed. Or it's x cubed squared 1, 0. Zoop. They're going up opposite directions. Works all the time. So if I went and did something like this where we had, actually, we go back here. I haven't written this one out, x to the 5th, but let's say we have x plus y to the 5th. When I do these types of problems by doing what's called binomial expansion, I do it in 2 steps. I deal with my variables and their exponents first, especially if there's no coefficients. Are there coefficients here? So all I have to do is write it out. I know I'm going to start with x to the 5th. I know I'm not going to have a y, but the next one's going to be x to the 4th and a y. X cubed, y squared. Notice I'm giving space between them too. One goes down, the other one, while the other one goes up. And now I just have to figure out my numbers. Numbers work out pretty quick. We already had it written above here. What's 1 plus 4? 4 and 6? 6 and 4? And 4 and 1. Yes, ma'am. Oh. X to the 0.
So 6 would be 6, 1, 6.
Yeah.
So if you wanted to do that direct, we just keep on going?
Yep. It's an infinite triangle. But there's a pattern here.
Okay.
There is a pattern that deals with combinations. Okay. What's happening here is that, excuse me, as you're going through this, these numbers, all of these numbers in the triangle match combinations. So if you don't know what you're doing, and you know you have a 5th degree polynomial, it's 5 choose nothing. 5 choose 1, 5 choose 2, 5 choose 3, 5 choose 4, 5 choose 5. And that'll be the coefficients for all of the binomials. That's how you get that coefficient. If it's going to be a 7th degree, if it's going to be a 7th degree, what would my C values look like? 7 choose nothing, 7 choose 1, 7 choose 2, 7 choose 3, 7 choose 4, 7 choose 5, 7 choose 6, and 7 choose 7. That's going to give you your coefficients. Now, the curveball comes in when your values in the binomial already have a coefficient, like 2x plus y. That means I'd have to take that 2x and raise it to the 7th power, because that's the whole chunk. Okay? That's what the part that you guys will mess up, because you forget about it. But wait! I have a shortcut to show you how to do that as well. Crazy how this works. That's pretty easy. So let me show you an example. Let's say we have, let's 2x plus, let's do it with one of them. 2x plus y, and let's go to the 7th power. I don't want to FOIL that out 7 times. That's a whole lot of not fun. It does. So here's what I do. Remember how we did U substitution before?
Yep.
You substitute in U for something to make it look easier. I'm going to do that with both of these parts. So instead of 2x plus y, let's make it more fun. Let's make it 3y. Let's just rip the Band-Aid off and jump into it. But I'm going to use a and b. Let a equal 2x and b equal 3y. And I know Caitlin's about to ask me, what happens when the signs are different and then what happens at subtraction?
There is no subtraction.
There is. It always starts positive. If they're positive inside, everything's positive. If it's negative in the binomial, it starts positive, then it goes, then it goes, then it goes. It's alternates. So Caitlin, you don't have to worry about that. So I get A plus B, 7. Write out everything in terms of A's and B's. Below that, I'm going to write down my C values that I'm going to use. I want you, do you see something that's happening?
It goes about with this.
What you're choosing, see 7 choose 0, 7 choose 1, 7 choose 3 and all that?
Oh,
That 0, 1, 2, 3 is following the exponent of the second term of the binomial. It's a nice little reminder. Also, notice that your exponents, what do all your exponents add up to equal? 7. They have to. If they don't, you don't move. Now, in my calculator, I know that I can do these, I hope. So I'm going to have 1. Now, I'm going to substitute back in here. It's a to the 7th. What's a? 2x. So it's going to be the quantity 2x to the 7th. Plus, well, what's 7c1? 7.
off one.
So it'll be 7 times 2x to the 6th times 3y. $21. So it'll be 21, 2x to the 5th, 3y squared. What's the next one? 35. 2x to the 4th, 3y cubed. That's the 7c3, not PO. 35 again, then we're on our way down. Plus 35.
35 again?
Yeah. 2x quantity cubed, 3y to the 4th, and then it goes back to 21, 7, and 1, correct? You'll notice that all these patterns, they'll work their way up, and then they'll work their way down with the coefficients. So once you get a duplicate, the exponents are just everything else will repeat.
Like, why does it go down? Why does it go 35 plus?
Because we have an even number of terms. There are 8 terms, and there's 8 terms where you'll have a duplicate in the middle. If you had an odd number of terms, you'll go up to 1 and then work your way down.
So you go up to 7, choose
Plus
3.
You go back down?
Yeah. And then this one is 21, 2x quantity squared, 3y to the 5th. Yeah, they could get, I kind of given you a really, really long, annoying one just to show you that it's the worst it can, yeah. But everything else, it's just all, the main thing is that remembering that you have to distribute this exponent to both parts when you're in here. That's all. Then we're back to what, 7?
Yeah.
So 2 to the 7th is what? 32, 64, 128? Is that right?
Sounds right.
Yeah, 1.8.
So I have 128 x to the 7th plus 64 times 21 ends in a 4.
2 to the 6 is 6.
Right. What's that times 21? 1,344 x to the 6th y. Uh, 21, 32, and 9. 6,048 x to the 5th y squared. 35, 16, and 27. 15,120.
Wait a second. Wow, how did you get 128 for the first
2 to the 7th. And that's the thing, you have to remember, you have, when it's junk to the power, both pieces inside that monomial here have to be raised to 7. X to the 4th y cubed. What's next? What's that? Oh, is it?
15,
Oh, 15, 120 again? Count where I'm at.
Wait, no, I don't think you're the same number.
It's not the same number.
Because you have different A and B values.
I got it. 22,600.
Which
was
one
it?
are we on?
22,600.
Which one are we on?
We were on this one, right?
So it would be 35.
35, 8, and 81.
Yeah.
Okay. Now we have 21, 4, and 243.
Yeah.
25.
7, 2, and 3 to the 6th. 10,206 x y to the 6th. And 3 to the 7th is 2,187 y to the 7th. And my big, nasty, horrible looking expansion problem is done. That is the absolute worst case scenario for writing these out. Yes, sir.
Quick question, why, you were going in the 1,721.35, why did we duplicate 35 twice and then start doing
The Pascal's triangle does that when you
Oh.
have, what
that?
happens
Oh,
is
it's
that,
it's the ones
Yeah.
in the triangle?
yeah. What happens when you have an even number of terms? So whenever you have an odd exponent, an odd nth degree, you always have an even the number of terms.
Mhm.
That means that the middle ones are going to have a duplicated value
Okay.
because it works up to it and then it works its way down. You'll see that a lot. I mean, when you look at these here, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. You'll see that pattern occur quite often. Well, actually, it will always occur. The only other really weird part of this stuff, guys, is when we get into, I'm really off-centered on some of these things here, is when they're going to ask you to find a specific term within. If I asked you to find the coefficient of the x to the 4th term in the expansion of x plus 2 to the 8th. find the coefficient of the x to the fourth term in the quantity x plus 2 to the eighth. Which means, if it's going to be the x to the fourth term, thinking about how the values work, that's going to be x to the eighth, x to the seventh, 6th, 5, 4. Since that coefficient of the x value is just a single term, I don't have to worry as much about as when I will have one that I don't have that, and I'll give you one of those later. As you're going through this, if you have an 8th degree polynomial, and you're remembering how your c values work. This was c, it was 8, choose 0, 8, choose 1. What's this one going to be?
Wait, does 8 choose 1 go with x and 7?
Yeah. What's that one going to be? It's going to be 8, choose 4. Because this other part here is going to be 2 to the 4th, isn't it? That's how these work. Because you know that if the first term is the 4th, the second term has to have the x1 and then it adds you up to get to your nth value. So in this case, it also is a 4. So in order to find the coefficient, I have to figure out what 8c4 is, as well as 2 to the 4th and multiply them together. Does that make a little bit of sense? Yes, ma'am.
So, do you really even have to write all that out? Can't you just do like, if x cubed first, then just 8 times 4 is whatever, y, or
There's many ways to do it. I'm just showing you, this is kind of the tried and true way. There's a bunch of different ways to do it. There are shortcuts, absolutely. Just about. So 8 choose 4 is what? The 8, 7, 6, 5, then it would be a 4, 3, 2, and a 1.
Where do you know
Where are you getting these?
and where does it, why is it only 8 through 5 at the top?
So it's 70. So 70 times 16, whatever it is.
How do you do that?
Why is it just 8 through 5 at the top?
Yes, but explain it.
math out?
Yes,
The rule for what this looks like.
okay.
Just simplify. I dropped the 2 earlier from the 4 and 2 to get 8.
Oh,
So 3 goes to this, 2, that's my 7.
alright.
I think then now you guys should be able to figure out those other problems, 9 through 14, right?
Yeah.
Get those tomorrow and we'll do, if you did them, great. If you haven't figured it out yet, we'll do that. We'll do that for tomorrow, and then we'll start the, we're a little behind now, but oh well. We'll do actual probability tomorrow.
Oh, just the odds.
For the square one? Oh, yeah. Let me go look. I gotta find that answer real quick. Here's how the rectangle ones work.
Oh, yeah.
When you have the rectangle one, you had, what, 3 this way, and then 1, 2, 3, 5 this way.
There's 6.
You pick,
There's 6.
you take, I'm looking at the 3 by 5 one. So it's the 3 by 5 one.
Gotcha, I thought you were doing that.
Yeah, I'll show, the other one, it's kind of the same thing. So we do the 3 by 5 one, you have, how many vertical lines are there? 1, 2, 3, 4, 5, 6 of them. It says 6 of those, pick 2, and then there are 1, 2, 3, 4 horizontal ones, pick 2.
Why do you have to pick 2?
That's what it says too. Because it says,
It says that's 2 horizontal and 2 vertical.
That's fine. It says pick 2 horizontal, 2 vertical. So you have, this is 6 times 5 over 2. And this is 4 times 3 over 2. So this is 3 times 5, and this is 2 times 3, which is 15 times 6, which is 90. And you do the same basic thing for the other
Working
one.
on our lab.
Does that make a little bit more sense? It kind of gave it away when it says, yo, you have to pick 2 of them. Lisa.